We only have 8.5 minutes. We start with the first summary. Mario, do you start?
Yep, summary of the AI group, and I was basically still discussing, so it was a very successful and very interesting round. So we tried to tackle the AI topic, which is basically super broad, and we're discussing, and after a while we realized that somehow we are back in, let's say, traditional discussions about basically open data, about business models, as well about the current situation in US and China. And as a quick conclusion, in the end, AI can be a game changer if we basically come up with smart models for basically data sharing and as well own European solutions. But it's nothing too new. It's still software projects, it's still change management, and as our role as as MPs, or basically as everybody else working on a topic, is really to talk to people, to try to take away their fear and their scare, because in the end, it's algorithms, and most of the time, they're doing something good for us. Thank you.
Thank you. Second one.
Yeah, we had a discussion about the open and free internet, and we had participants of all continents of the world without Australia. That was the only continent missing, and we all have different approaches to that topic, and we came to the point that at the end some of the governments of the world and the parliamentarians are really too old to understand what's going on around them, and that we are in need to be fully aware of what's going on in the next 2 and 3 decades, that we as lawmakers are the ones who have to make regulation for the open and free internet that holds it open and free, and all the human rights should be there for the internet, and we are going to put all the points together and give them to all of you on Friday, I heard, so we'll see what's going on with our discussion. It was not enough time. We should have had an hour more. Parliamentarians who love to talk everywhere around, that's something special. To put them down after 2 or 3 minutes being president was a nice moment. Thank you very much.
Thank you. Anke, are you ready? Just 2 minutes.
I still have to look at this paper. So we had a very big and interesting and globally diverse group of members of parliament. And we're talking about all sorts of challenges. Yeah, that would be nice. We're talking about challenges like election interference, and learned, for example, that in Brazil there is a regulation. Okay, I get a little closer to the mic. We talked about how to deal with election interference, and learned that in Brazil there is a regulation being developed right now on forcing transparency. So I can't go into all details, but I understand the outcome will be collected by the secretary and be made available, right? Because that was a question. Okay, so we also talked about dealing with lock-in and network effects, about how governments can protect the data they have about people, and how to ensure internet access for all. Where is my second paper? It's here. It's hiding behind my back. Yeah, we talked about data protection and how the European laws can be a model for other countries and how they try to adapt that. And we also talked about the issue of interoperability and at what level it should be regulated, whether, for example, the UN could be the body being responsible for international regulation, or for a social innovation fund, and actually provide a social network at UN level for the entire world, which I found the most interesting idea we discussed. Thank you.
Thank you. Jens?
Yeah, thank you, Mr. Chairman. And we also had a great debate, very diverse from all around the world, truly UN spirit. And the first thing was that, of course, there is a debate on the UN level about rules and regulation in the cyberspace, but we had a certain agreement that it probably took maybe too long because there is no final solution to that problem yet. Cybersecurity, that was mentioned from our colleague from Estonia, should be very high on the political agenda, which is very often a problem that it is not. And something that is important is the cooperation with stakeholders from the private sector, from civil society, and we as parliamentarians and government officials, we're used to being in the driver's seat, and in the field of cybersecurity, it's necessary to have much more cooperation. Then the question and the debate that state sovereignty is something which is perceived very differently around the world, where some states see that having a closed net into their countries, and other countries have a more perspective on maintaining the global net. So this was something we couldn't agree on, but we have the same view. On the question of cyber defense and hackbacks, we debated intensively the problem of attribution, and I think we didn't came up with a solution to that problem, and it is a field for policymakers, definitely. What I probably liked the most is that it's necessary to train parliamentarians and government officials in the field of digital literacy. But in the same way, it's crucial to teach the IT people to speak like normal people. I like that, no offense here, but maybe we can agree all on listening to each other and speaking in a way that everybody's understood. So on that, thank you very much.
Thank you. Next time we need more time. You know. Dear guests, ladies and gentlemen, I'd like to thank you, all of you, for attending this parliamentary event, but even more for all your constructive contributions and discussions. We have had a very fruitful exchange of knowledge and opinions on a variety of important topics, especially concerning the future and the structure of the free internet and how we want to deal with it. I'm sure that within the next few days we will have more opportunities to intensify this dialogue and the contact between each other. The last 2 hours have shown how important this dialogue is, and it emphasizes that we are on the right way to give the IGF the importance and impact that it deserves. Last but not least, I would like to thank everyone who worked so hard to make this event happen, especially to Mr. Griedel and his department for the Ministry of Economic Affairs with their indispensable experience and expertise on working with the IGF. My special thanks go also to the office of Jimmy Schulz and Mrs. Langer. Without all your effort and your tireless contribution, Day Zero would never have been realized. Now we have a good fundament to start into an exciting and successful IGF 2019. The President of the German Parliament, Dr. Wolfgang Schäuble, invited all of you to another parliamentary event on Friday. It will be the perfect occasion to draw a conclusion, to exchange the experiences of the past week, and to look forward to the IGF 2020 in Poland. Therefore, I hope to see as many of you as possible again on Friday. One last organizational note: this session will be followed by a briefing meeting with further information for lawmakers about IGF participation. If you have any questions about the next days coming, they will be answered there. In addition to that, you get your key cards for the Executive Parliamentarians Lounge. Furthermore, information will be provided to you on the guided tour through the German Parliament. Hopefully you all take notice about the changed date of the tour. It will now take place on Tuesday from 7:30 to 9 p.m. It is free of charge and buses will be provided. If you are not registered yet, please use your last chance at the briefing meeting. Once you have chosen to join the group of visitors, don't forget your passport or ID cards tomorrow. The tour will be held in English only and is limited to 50 participants. Thank you very much for your attention. And now we have to follow for the following session to Sandra Hoferichter. Thank you very much.
Could I, your attention please? Could all members of parliaments be gathered at the entrance door to leave for the parliamentarian lounge, please? Thank you. Once again, your attention please. All parliamentarians, members of parliaments are being requested, kindly requested, to gather at the entrance door to leave together for the lounge and be guided to the lounge. Thank you so much. Excuse me once more, this is the final call for all MPs, members of parliament still in the room, together at the door and to follow me to the parliamentarians' lounge. Thank you.
Okay, good afternoon. Well, this is the big one after the parliamentarians have been briefed. Now we're actually going to get into the meat of the subject, which is really important. My name is John Denton. I've met a number of you and I've had an opportunity to speak at a number of events already during this very important IGF. I'm the Secretary General of the International Chamber of Commerce, and it's interesting for us. This is our 100th year, and we issued a declaration for the future, which has been, it's actually one of those extraordinary things when you think about the size of the ICC. We are the institutional voice of 45 million businesses, and we celebrate our 100th year this year. And I think the general habit is to look backwards and say how wonderful you are, etc. What we did instead was to look forward and say, well, what is our intent? What do we want to achieve in the next 100 years? And one of the most important elements, as you can understand, is when we were founded, what was a digital economy in 1919? In 2019, one of the big changes that we see, which actually are incredibly relevant to the currents and opportunities for business, is the digital economy. So we made a commitment, amongst others, as well as a commitment from the whole of the ICC to science-based targets on climate. So we actually committed to 1.5 and to net zero as well. So that's the commitment from the whole of the ICC, and there are no one's holding back. And if they do, they can't actually align with what we're trying to achieve. We're doing the same thing in the digital economy, which is we want to ensure that the ICC plays a critical role in supporting business. But we're doing that because the whole purpose of the ICC is that we enable business because we see business as a force for good, and we enable business to secure peace, prosperity, and opportunity for all. So we made a commitment around the digital economy, and we've also made a very big commitment then about looking at the issues that could impede the facilitation of the digital economy for business and for us to achieve our purpose. And one of those issues is around governance. Another issue is around inclusion, access, etc. So we're running a campaign this year, and I launched it last night, one of 5 campaigns, but a particular campaign relevant to here, which is to make technology work for all. And by the way, we don't only talk about it, we actually do it. We have our own digital hub in Singapore where we've created blockchain solutions, which frankly, the intent is to enable democratization of access to blockchain for SMEs and micro SMEs on a global basis, particularly around traceability. We've actually just done the first digitalized trade flow from Africa through Singapore to China. It's the first time anyone's taken that documentation from analog to digital. So we see the digital world as actually enabling business and actually creating opportunities for all. The purpose of the discussion this afternoon, though, and actually it's always kind of funny that it takes place after the ministers have all left, because one of the great dangers in life is you govern things you don't fully understand. In business, we say, if you can't measure it, you can't manage it. But in international governance, sometimes you don't understand it, and yet you try to govern it. So what we always try to do with ICC at the beginning of IGF is to give an opportunity for people to understand what is it? What is this thing called artificial intelligence? How does blockchain work? What is 5G? What is IoT? What are smart cities? And if we can bring some more knowledge and some substance, then it informs, I think, better conversations during the course of this week. And so that is the purpose of today. And from the ICC's point of view, that is also about enabling business. That is actually supportive of our campaign around Make Technology Work for All, and it's very real for the 45 million entities which are the users and the adherents to the ICC purpose, which is securing peace, prosperity and opportunity for all through the private sector. So if you're going to talk now a little bit and introduce our speakers, and I look forward to being better educated so I can govern better by the end of the conversation. Thank you.
Good afternoon. Okay, here we go. Good afternoon, everyone. It's lovely to have you all here. Thank you for coming, so many, to our crash course. Before I introduce the speakers, I want to talk about what is on the screen. It's not coded language or anything like that. It's a system that's going to allow you to join in, because we're not only going to be talking about emerging issues, we also want to talk about them with you. So we're going to be encouraging you to log on. There are also some papers that are circulating. You may have received them. You can screen the QR code, and that's going to allow you to log on your questions to the different speakers who are going to be taking part in the session during the afternoon. I really do encourage you to join the conversation. Please don't be shy, because we want to hear from you, and it's going to allow the speakers to react in real time to the issues that you would like to know a little bit more about. So as John mentioned, BASIS has been organizing this type of crash course presentation for quite a few years now, and we're looking forward to doing that again today. And the reason we've done that is that we've noticed that the people coming to the IGF have different backgrounds, have different levels of knowledge, and we think that this is a really good way to create a kind of level playing field where we all come to the table, we hear some experts talking about some emerging issues that are going to be high on the agenda or hot topics that you want to know more about. And so hopefully this is going to help you feel better equipped and empowered to take part in the IGF, but also be an active player both during the sessions and when you walk around in the village. Oops, there goes my nameplate. What are we going to be talking about today? Quite a few important issues, and John's mentioned them, among them artificial intelligence, blockchain, 5G, IoT, smart cities. And here we have the names of the people who are going to be presenting the experts. And because we're running a bit behind schedule, I think I'll just jump in. And I'm going to briefly present now Marit, who has extensive experience and expertise in telecoms, broadband, and internet matters. She's coming to us as a regulatory affairs director at ETNO. She joined ETNO from the Internet Society, where she served as a senior manager Europe, and where she has acquired a strong experience of broadband policies as well as extensive links with internet and tech stakeholders. Marit has also direct experience of the telecoms business during her 6 years at Cisco, and she developed a strong service-oriented, hands-on profile acquired in leading consultancies, Interrel and Schumann Associates. So Marit, we look forward to being further enlightened about 5G technology, and the floor is yours.
Thank you very much. Thank you for the kind words, and our communications people are very good at writing those biographies, so thanks very much. 5G. So first maybe to say a few words about ETNO so that you will understand my angle and my perspective. So ETNO is the European Telecommunication and Network Operators Association, and we represent the largest telecommunication operators in Europe. So we have about 33 members, I think, at the moment. And in terms of the infrastructure footprint, our member companies, they currently, the part of the investment is about 70% or 65 to 70% of all telecommunication infrastructure investment in Europe. So I think my presentation will be flavored with a bit of a European touch, but I will also try to keep in mind the global presence here at the IGF. What is 5G? We hear this buzzword all around. We are based in Brussels. It's in the policy discussions at the moment. There's a lot of hype around 5G. There's a lot of questions as to, do we need it? Is it good for us? And so forth. So I'll try and kind of give you some tasters from our side of view, our point of view on the topic. So technically speaking, we think that 5G is a major game changer in the telecommunications world. So 5G will bring the fixed networks, so mainly fiber in the future, and the new generation mobile communications together into one smart network. And with the help of virtualization, this network can then be used to provide tailored services as well to industries and to consumers. So the whole kind of architecture behind mobile technology has evolved and will enable us to do that in a more effective ways. And just, I'm not sure, I don't think there are many technical people necessarily in the room, but in terms of the network performance, there will be clear differences to what we have today with 4G and 3G. So speeds will be even higher than before. We will have faster network response times. We call this the ultra-low latency communications. So this will be crucial, for example, for emergency services. So we will be able to use mobile communications in the emergency scenarios as well. We'll have the capacity to support higher number of devices in a certain area. And we know already today that in certain European capital cities, for example, during a rush hour, where people are commuting and they're all on their mobile devices, watching Netflix or gaming away, that we are at the very peak levels of 4G in some cases. So there's real need, at least in the urban areas at the moment, to upgrade the technology. But we should also think a bit wider than that. So it's not only about networks, 5G. And if you really think about the transformational impact of 5G, it only happens when the networks and the services enabled by the 5G networks meet the demand. So demand by industries, demand by public administrations, demand by consumers. So we really need to make sure that when we are talking about policy or other things, that we take the whole ecosystem and the equation into consideration. What about the benefits? So what would a regular citizen see? How would a citizen see 5G impacting our communities, our societies, our economies? So rather than going into a lot of theory, just a few examples. So with 5G, for example, in the future we could imagine, I don't know, a skilled surgeon offering services to faraway patients through 5G, through mobile networks, or a drone delivering defibrillator devices to an emergency scene somewhere in a remote area. Fire brigade having a better understanding of what's going on in the field before they go and tackle fires. Similarly, a municipality, for example, in extreme weather circumstances, being able to understand what the environment is like before they make decisions on how to handle the situation. So we really believe that the transformational change for citizens will happen at this service delivery level. And this will impact everybody's lives going forward. Now, in terms of economic value creation, there we have there's maybe a bit more of scope to 5G and also perhaps more unknowns. So we have new technologies that 5G will provide bandwidth and capacities for, such as artificial intelligence, robotics, remote controls. So we could imagine that going forward, for example, in a mine somewhere, which is a dangerous industry, that all the machines would be operated through a 5G network. And hence, this would, of course, increase employee safety and so forth. At the same time, there will be a lot of economic and operational efficiencies that will also be driven by 5G. So we, all in all, there's still a lot of work to be done between also us, the telecommunication operators, and then these different industry verticals, whether it's manufacturing or cars or healthcare, to understand exactly what kind of services and solutions will make the 5G ecosystem valuable for our economies. But the work has already started, that's the good news, so we are very positive on that point. Now, I talked a lot about the positivities. So do we have any concerns? And in Europe especially, we have at the moment a lot of public discussion around 5G. And there are especially questions related to security, safety, and also sustainability in terms of the green impact of 5G. And I think we would be the first to say that these are all legitimate questions, because in order for any new technology to work in the long term, we must establish trust in that technology. So we shouldn't hide away from these difficult questions, but we need to try and together discuss them, and also provide, as it may be, scientific, factual evidence to back up our choices of technology in this sense. I mean, 5G is backed up by strong global standards. So the 5G standards have been developed in a collaborative way between different standardization organizations. So we have a kind of firm compliance criteria, if you like. In terms of security, of course, there's a lot of talk about security at the moment. 5G is actually in a better position than, for example, 4G was when it was being built. So 5G is benefiting from this privacy by design, security by design thinking already now. We have new security technologies at our disposal, such as network slicing. We can use virtualization, authentication, encryption. So we have a much better starting point than we used to have with the previous generations. So in a way, we are working about this, but we need to discuss and continue discussing so that we are all feeling comfortable about this. There's also discussions about safety, also in terms of public health, the radiation of 5G. But the scientific research over the last decades and the facts that we are seeing hasn't given us any concern in that regard. And even going forward with 5G, the radiation levels will be remaining well below the currently defined limits in terms of radiation. So those were some of the concerns in the 5G landscape. So perhaps would be interesting to also touch upon, so where are we actually today? Where are we in terms of deployment? It has to be said that it's early days for 5G everywhere. But our comms director has actually given me a permission to give you a sneak peek about what we are forecasting in terms of global leadership in 5G. So at ETNO, we do a report every January called The State of Digital, and we are currently just finalizing the data sets which will be published in January. And Analysis Mason, who is helping us with the report, are foreseeing that in 2020, Asia will be globally leading quite far ahead in terms of 5G. And this is it's very important to say this is in terms of absolute numbers of 5G connections. So this is not really taking into account the whole ecosystem of services and that I discussed before, but simply the 5G connections. Asia is then followed by the Americas, includes North and South America, and very close behind then by Europe. So Americas and Europe are more or less on a par. And then on a fourth place, we have Middle East and Africa, where there's quite a long lag. They're quite far behind. So that's the kind of global picture. And as I said, though, we should look at these numbers very carefully, because it is not only the number of connections that count. And I can, from ETNO members' point of view, say that there's a lot of work going behind the scenes in terms of the deployment. We are bidding for the spectrum auctions. So in Europe, only 15% of the 5G spectrum has been assigned by now. So it's absolutely impossible to roll out infrastructure in some countries at the moment. However, in the meanwhile, there's a lot of investment going into use case trials with different industries, so use cases for healthcare, for manufacturing, etc. There's also quite a lot of already small-scale commercial launches in urban areas, in big cities typically. And what is not always so well known is that telecommunication operators are now also investing quite heavily in data analytics and cloud infrastructure. Because as 5G, it implies directly, of course, that data volumes will increase quite dramatically. So we have to have the capacity then actually to process this data and manage the data. And final point is the sustainability and the green factor, if you like. So 5G also offers us a great opportunity to rethink a bit our network infrastructure, and to make sure that with the kind of global effort on trying to be more environmentally conscious and environmentally friendly, that we can also use this upgrade of the networks to serve that purpose. And it's not only about the carbon footprint of the networks, but it's also to make sure that the services that will be built upon it will then indirectly reduce carbon emissions, for example, in transport, etc. So then my recipe for success in terms of policy, what do we need to do to start preparing not only Europe, we are already kind of on our way, but also in other parts of the world, what are the things that we need to pay attention to? I already alluded to the demand side of things. So in Europe, but I also think in much of the developing world, there's a tendency to measure success in connectivity by supply side targets. We need to connect this and that many million people by this and that date. We need to now also think about the demand. Demand side targets are needed. There's also a gigantic investment leap that is needed to make 5G happen. And we need the regulatory and policy framework to be supportive of that in general. And we have gone through a massive exercise in Europe of updating the whole regulatory framework. And we're still working to make sure that that will be favoring the investment that is required. Finally, governments can facilitate reduction of deployment costs. And this can be through spectrum auctions, so there are pricing options available, but also then streamlining procedures at local levels in terms of permissions and other things, sharing of infrastructure as well. And then the kind of sustainability question at large. So 5G needs not only to be sustainable in economic terms in terms of the business case, but we also then need to make sure that it is sustainable in terms of energy and also in terms of its societal impacts. So I hope you have kind of heard that in terms of the 5G development, there's a role for everybody. And, you know, governments have a role, operators have a role, big industry has a role. We need innovators, startups to come up with the services and solutions. And we also need the consumers, the individual citizens on our side. And I think also the civil society plays a key role here to make sure that we have the discussions that we need to have about 5G and to have that trust that we need to launch it as a framework. So in the kind of spirit of the IGF, I invite you all to participate in this discussion about 5G development. Thank you.
Thank you, that was extremely helpful. I'm wondering how we're doing with the questions from the audience. Yeah, I really need a pair of glasses, I cannot read that.
Do you want me to help you?
Can we make that a little bit bigger? No?
No.
Okay.
There are some questions on health. What about the discussions about health and 5G? Is it a new risk for health? And another one, what are the health concerns of 5G in terms of EMFs?
So I was alluding to the radiation, and this is the same thing as the EMF, so electromagnetic fields is the official term. And at the moment what is happening is that we have a global independent agency called IGNIRP, which is under the kind of umbrella of the World Health Organization, who defines the health limits for this EMF and radiation from mobile antennas specifically. This is a different radiation than from devices, it's from the antennas. And in 4G, we currently have limits, and the limits are well above the radiation levels in real terms. And in terms of 5G, the current limits will still be protective of the radiation that we are foreseeing in terms of the 5G. It has to be said that this agency is currently reviewing their guidelines in this regard, but we expect that there won't be any radical changes. But this is one of the discussions that I think needs to be clarified, and we are also very much calling for further scientific research into this and factual kind of data around this from organizations who are in a position to do that. In Europe, that could be, for example, the European Commission or somebody who has that kind of position. So I hope that clarifies a bit, but
yeah. Okay, thank you very much. Thank you, Marit, for being very clear and concise and bang on time. So that's, now that we're experts in 5G, I'm going to be turning to my colleague here, Ben, from Microsoft, regulatory policy analyst at Microsoft, where you focus on regulatory and policy solutions for extending connectivity to the next billion. and on contributing to the success of the multi-stakeholder model of internet governance through engagement in forums such as the IGF, that we're all familiar with, of course, ICANN, and the ITU. Ben, you previously worked on international telecoms policy for the UK communications regulator, during which time you served as vice chair of the OECD's Working Party on Communications, Infrastructure and Services Policy, and co-chaired the BEREC, sorry, I can't read that, Net Neutrality Working Group, and which produced guidelines for implementation of the EU Net Neutrality Law. So thank you so much. We have a presentation to look forward to, and I'll give you the floor. Thank you.
Thank you, Sophie. And so we've just heard about connectivity, and I'd like to talk about a few things that can be done with that connectivity. Microsoft is at heart a productivity company, and we see digital transformation as central to achieving our mission, which is, as you can see on the screen, to empower every person and every organization on the planet to achieve more. And IoT, the Internet of Things, is increasingly playing a key role in helping us to achieve that mission. So let's start with a definition. And I'm sure there are many definitions of IoT, but here's one. IoT is essentially the digitization of the physical world. By connecting things and collecting enough data about those things, you enable a full digital representation of the physical object and its operating environment. And you can then apply technologies such as big data, machine learning, to gain helpful insights from that data. Now, Microsoft doesn't make IoT devices. We don't design or run IoT networks. What we do is we look at how technologies like cloud computing and data analytics can work with IoT devices. And we approach IoT with the belief that small IoT sensors, big data, and human ingenuity can help to solve some of humanity's biggest problems. So, Microsoft has an AI for Earth initiative, and that involves researchers and scientists looking at critical challenges in water scarcity, biodiversity, climate change, using the power of cloud computing and IoT and big data. And in the brief time I have today, I'm going to talk specifically about another one of those areas, which is agriculture, by looking at some connected cows and at a dancing crow. We're going to briefly explore how IoT and data-driven technologies can bring improved efficiencies to agriculture and contribute to sustainable development. So in this case, SDG 2, around the elimination of hunger. So let's start with some connected cows. These days, pretty much every company has the potential to be a data company, even ones you wouldn't expect, even dairy farms. Farms have all the constraints of a typical business. They need to maximize output under the constraints of the fixed assets they have. And I really like this example of the connected cow. Let's have a look at some cows. So if you notice the pedometers on their legs, they're connected to the farm's Wi-Fi network, and they're sending data into Microsoft's Azure Cloud Service about the number of steps the cow is taking. Constantly, every step from the cow in the dairy farm is being counted. So I wonder why that is. Well, I said that dairy farmers need to maximize output. One of the ways they can do that is to maximize calf production and get bigger herds and herds which have the makeup that they need for their farms. And they can do that by the accurate detection of estrus. Estrus, as you might remember from school, it's a scientific term for when an animal comes on heat, when it's most likely to conceive. And detecting estrus is very important for a successful artificial insemination program to give you a high percentage of pregnancy. It turns out to be harder than it looks to detect estrus because it lasts only up to 18 hours and it happens mostly overnight when the farmers are hopefully tucked up in bed. So this is where the human ingenuity steps in. A farmer in Japan asked our partner company, Fujitsu, to help with the problem, Fujitsu consulted with a university researcher, and they came up with this clever detection system that combined artificial insemination with artificial intelligence. And this is the system which resulted. It's called the Fujitsu's Jiayu service, cow step service. And so the step count data, you can see in the bottom left, from the pedometers on the cows are sent over the Wi-Fi and the internet to a service on Microsoft's Azure, in the top right there, and that analyzes the data and then produces alerts for the farmer. So it turns out there's a simple secret to detecting when a cow is in heat. At the onset of estrus, there's a marked increase in the number of steps that a cow takes. When the cow feels hot, she starts pacing furiously. And you can detect this by a simple day-by-day, hour-by-hour comparison. And so this chart illustrates it well. The x-axis on the bottom is the time of day, and the y-axis on the left is the number of steps taken. Now, this is the normal number of steps on a normal night by our sample cow. This line is the number of steps when the cow goes into estrus. And you can see the number of steps per hour just shot way up. Now, it turns out the signal is about 95% accurate for detection of estrus, especially in a controlled environment such as a dairy farm. The optimal time for artificial insemination is 16 hours from the onset of estrus for the maximum conception rate. So that's the point at which AI meets AI. And there's more. So it turns out that there's also this 4-hour window on either side of the optimum point. And if insemination occurs in the first half of that window, the result will probably be a female, and in the second half, a male. So farmers could actually manage the gender for what they need in their herd at any particular time. So that's a funny story. I think it's a good demonstration of how new technologies underpinned by the cloud can revolutionize one of the oldest industries in the world, such as farming. So moving on from connected cows to that dancing crow. Dancing Crow is actually the name of a farm not far from Seattle, where Microsoft first pioneered its own research into precision agriculture. The project is called Farm Beats. The idea is to use AI in farming to augment human knowledge and help increase productivity and decrease costs for the farmers. So I've got a short video that we'll now watch from Dancing Crow Farm. And Angèle, you just need to click to activate the video. Thanks.
This area is known as Stewart's Landing, and this is Dancing Crow Farm.
One of the world's problems is yield. How do you double the yield by 2050 to feed the growth of the population in the world? This is a project that we recently started. What we want to do is we want to enable data-driven farming. The first goal is to give a real-time view of the farm, the real-time pulse of the farm to the farmer, saying, hey, this is what your farm is doing right now. So how do you even connect these farms to the internet? It's so far remote, the cell carriers have very little incentive to provide connectivity in the farms.
The system that we have deployed here is measuring soil temperature and moisture, and it's coming from this sensor.
Here what you see is a white spaces device. The idea that we had was a farmer buys a white space router, plug it in the farm, and your entire farm is connected. Now you can connect multiple devices, and connectivity is cheap. So you can actually deploy many more sensors in the farm. You could have a dense deployment of sensors getting real-time view of all the parts of the farm. Not only your soil or moisture data, but this is a high bandwidth connection. You can connect cameras, get real-time views from the farm. So once you have all this data, you could then analyze the data to predict what the future would look like.
I'm actually really looking forward to how the process will change. This last year has been mainly a data gathering, information collecting year for the Microsoft research team. I'm really looking forward to seeing what research they've gathered this year, putting that together with what I think is going to happen next year, and make predictions for what I should plant when and where.
So I can kind of recap what we saw in that video, and there's a lot going on in this slide, so don't even try to read the smaller writing there, and I apologize for that. But this particular version of precision agriculture uses the IoT sensors that you can see at the bottom of the screen there, and imaging data which is provided from drones, or in areas where drones are not permitted or not affordable, you can tether balloons and float them above the fields. And they can be sent up to take pictures. And then the data is analyzed using machine learning algorithms, the results provided to farmers, and gives the farmer precise information about soil temperatures, soil moisture, so they know exactly when the best times are for planting, for watering, for fertilizing, and as well as exactly how much water they need to use and fertilizers needed. And this isn't just a project for farmers in the developed world. There's a project in Kenya run by a company called Sun Culture. Sun Culture's business is to help farmers improve their crop yields using solar-powered irrigation systems, and it also provides the financing for the low-income farmers to be able to buy those solar-powered irrigation systems. And so Microsoft has worked with Sun Culture to expand that project by including sensors, including camera technology, and drone imaging capturing. And so by doing that, we've helped to improve the soil monitoring, the data collection, and the quality of the crops that they're producing. And just to give you a sense of the impact, one of Sun Culture's customers is a small-scale farmer who she used to have to fetch and move 20 liters of water at a time by hand. Now the irrigation system nourishes her crops and her livestock, and it saves her apparently 17 hours a week, and it increases her productivity and her income. So just to sum up, precision agriculture technologies empower farms by making it easier and more predictable to manage their dairy herds, as we saw with the connected cows, and by enabling farms to make more efficient use of scarce resources and raise better quality, high-yield crops. And by looking at these two examples in just a single area of agriculture, I hope I've given you a sense of how Microsoft believes that the cloud and data analytics services can be combined with the Internet of Things to make a meaningful contribution to digital transformation.
Thank you, Ben. I'm just wondering how we're doing with the questions, Angèle?
We have more questions on 5G, but no.
Okay. Does anyone have a question you want to pose with a microphone?
Thanks, Ben, for this excellent example of where we are moving. But if this system is somehow insecure, just imagine what an actor, malignant actor, could do destroying a crop or destroying a herd or whatever through this Internet of Things. Is that part of the product as well, that all these services are secure?
So the projects we've looked at are single farms, so they're kind of in a contained space. But of course, and everyone's networks are at risk of cybersecurity. I don't off the top of my head know the particulars of the security components of Microsoft's Azure products, our cloud computing products, but I know it's something that they've done a lot of work in. They've produced white papers on IoT security, security of devices, so I would be confident that it's something that's wrapped into any cloud computing services that are purchased from Microsoft. But that's obviously a more general question for the industry as a whole, and so we then work with others through things like the Cybersecurity Tech Accord to kind of encourage companies to adopt best practices in this area.
Thank you, Ben. We have time for one more question.
Yeah, thank you very much, Tilman Kupfer from BT. When we talk about green ICT, we think more about decarbonization of the economy, reducing carbon footprints. But this is another form of green ICT, I would say. Do you have any ideas how that actually also could help to reduce use of pesticides and of chemicals and fertilizers, etc., and to move more for also green agriculture?
I think what was interesting about the second example was, I guess it would prevent overuse of fertilizers, and because you're only using them when you need them. So as well as the being more efficient and decreasing the cost, that's also a way of avoiding overuse of things which might harm the environment. But I'm not sure that the project has looked in particular in that area. We have other parts of our AI for Earth are about helping monitor biodiversity and looking at ways to deal with climate change. So those are other examples, but not particularly in the area of chemicals used in farming.
Thank you very much, Ben. Moving right along, we're going to be talking about AI. It's my pleasure to introduce to you Cédric Archambault, a principal applied scientist, machine learning. Cédric is leading the science underpinning several machine learning and AI services offered in Amazon Web Services. These services put machine intelligence in the hand of every developer, enabling them to build intelligent software applications. His goal is to advance machine intelligence to benefit people. He's a guest speaker in the statistics department of the University of Oxford. He holds over 10 US patents, and he also serves as the reserve member of the high-level expert group on AI at the European Commission. Over to you, Cédric.
Thank you. So today I would like to talk about machine learning, try to probably demystify a bit what machine intelligence can do and cannot do. And I'd like also to give you a couple of examples where we use machine learning in applications at Amazon. I don't know if some of you have already seen this picture before, but so this is essentially a machine learning model, like a neural network, that was developed at the end of the 90s, and it's called the Net 5. And what you see on the bottom is like a couple of digits, written handwritten digits, and then on the top you see answer, which is like guessing, the machine is guessing which digit it is seeing. So those are just images of handwritten digits. And this system was developed at the end of the 90s, beginning of the years 2000 for detecting and recognizing banknotes in the US, and was handling 10% of the checks written by people. So this is to illustrate that machine learning has been around for quite some time, has been used also in production quite successfully, and it's only recently that there was some form of acceleration in the domain of applications of machine learning and AI. So what is machine learning? Well, one example that I just showed you before is connecting to essentially recognizing objects, or in this case digits. And at a high level, well, you can think of machine learning doing the following task. So it's essentially working very similarly as how people learn. So for example, if you have like this picture of a chair, well, parents could tell their kids that this is a chair, and sometimes later, well, the child is seeing this picture, which is a sofa, and say, oh, is this a chair? A chair. And then the parent would say, well, no, this is not a chair, this is a sofa. So great, this is a sofa, so I've seen a chair, a sofa. Sometimes later, well, the kid is seeing this other picture and says like, oh, this is a chair, yes, this is a chair. So you get a couple of examples of chairs and sofas. And over time, the kid is going to learn, well, what is a chair and what is a sofa. And so when the learning process is essentially at a very high level, you have like those pictures of chairs and sofas, and you want to be able to recognize this new object there. Is this a chair or is this a sofa? And so what machines, like when people learn those concepts, well, they need a couple of examples, just like one or two, to make good predictions. So the big difference when you look at machines, well, they need like hundreds of thousands of examples before they can recognize, for example, a chair from a sofa. So the efficiency with which you can learn with machines is way slower than with like typical humans doing. So the problem that I just described is called the classification problem. And essentially it's called the binary classification problem. And so if I return to the example of, well, recognizing digits, well, here on the left you have an example, a couple of examples of small images of digits put next to each other. And the question is whether a computer can recognize, well, a new image, an image that it hasn't seen before, and say whether this is like, for example, a digit 8 or some other digit. So I can simplify the problem, like in case of digits, you have 10 digits. So and say, okay, we only have like 2 digits, which is then a binary classification problem, and assume you have only 9s and 8s, and here x1 and x2 are just like pixels, pixel values, and assume you just have 2 pixel values to represent those 9s and 8s. And so you get like 2 groups of those images, and so the goal is to say, well, when you have this new image there, is it like an 8 or is it a 9? So more traditional techniques might say, well, you can look at the lookup table. You can try to memorize all the previous examples of the 8s and 9s you've seen in the past and say, well, now I want to assign a label to this new image. And the problem is that this type of technique doesn't work because you have never seen that image before. So you need to have seen an image before you can make a decision. So when we talk about machine learning, well, machine learning is going to learn, like in this case, a decision boundary, what you call decision boundary, which is going to separate those 2 classes. And when you have like learned this decision boundary, well, then you have this triangle that you can say, well, this is probably a 9 and not an 8. So this is like a basic binary classification problem. And so what are those classification problems then useful for? So I'd like to talk about like 2 very simple examples or like straightforward examples of applying classification in practice. So the first one is automatic review moderation. So when we look at, here it's not like images, but it's like text. Look at reviews on Amazon. Well, anyone can write a review, and the scale at which reviews are added is huge. So 2 years ago, like around like 300,000 reviews were added every day. And so you cannot check every review, whether it's relevant, whether it's like, has like okay content to post online. So you have to double check that this, well, it's like, there's no obscene or whatever type of content. And so you can use a binary classifier to look at the text and decide whether this, well, review is okay to post, is not okay to post, or has to be checked by a human. And this helps really improving the customer experience and helps like to provide more relevant information to the customers. A second example is quality assurance of images. So when we sell products online, people want to see like an image of that product. And we need to double check that, well, the quality is guaranteed. And for example, we want to have like a white background. So detecting whether an image has a white background or not is again, can be viewed as a binary classification problem. You want the product to be big enough. Again, this is a binary classification problem. You, for example, want to see whether the object is a real picture of the real object and not like a picture, like in the right case. So all those cases are instantiations of simple binary classification problems, very simple decision-making problems, that when you have enough data, you can start automating and doing that with some confidence. And when you're unsure, well, you can send it back to humans that can double-check whether this decision was correct or not, or provide new data to train on. So why is machine learning today like really creating a paradigm shift in industry? Why is it so successful and so popular? And there are a couple of reasons for that. And probably one fundamental reason is that it's enabling you to make data-driven decision-making. So if we look at how traditional programming works, well, we might have some data, some software developers are going to write a program, and the program is going to execute on a computer, use that data, and produce some output. The time you have to spend to develop this program, in some case like I mentioned before, like detecting okay reviews or not, or detecting whether an image can be posted online or not, is taking a lot of time. You have to think about all the edge cases, all the exceptions, so that you cover the potential use cases that you want to target. Now, when you think about machine learning, well, here you're going to revert the way of approaching the problem. You're going to look at examples, data, and output, like, for example, an OK review or not, or this object or this other object. So you're going to, there is like a program is going to be executed on the computer, take those pairs of input and output, and produce a program as output. So the production of the program is what we call the learning. But the prediction is still operating the same way. So whether this program has been hand-designed or has been generated in a data-driven way, it's still can be applied on new data to produce new outputs and new predictions. So a slightly more advanced use case, which goes away from the binary classification problem, is understanding fashion and style online. So when people browse or search for fashion attributes, well, you can have like a predefined set of dimensions, like the brand, the color, the cut, etc. But those are very rigid ways of searching and browsing products online. And so you might want to have a more like natural way of finding and searching products. And so you want to find like good similarities between products, a bit like more like humans would do when they go to a shop and they're going to browse all the possible products that are available in the store. And so you can use machine learning to learn those kind of representations, like more natural representations based on how people like used, for example, the website and purchases that they made. And so you end up with like results like of this kind, where we have a target image on the top left of this dress, and then we have learned a similarity that returns all the other dresses that you see at the bottom. So you see that those dresses capture some form of similarity, which is not only the color or the brand, but it's capturing some semantics of those products and capture some similarities that are more intuitive, probably to the user. So these are the types of results that you get when you use machine learning for like searching over the catalog without any filtering. So there's no filtering of other products. This is just returned by the algorithm. And similarly, you can use the same type of algorithm to browse other items, like for example, pieces of art, where again, you have like the top left picture is the target one, and then you return all the most similar other items in the catalog at the bottom. So today, because of the power of AI and really to scale and provide like new customer experiences and be data-driven, well, AI is being used in a very broad range of domains, not only well for search and discovery, I gave a couple of examples, but it's also used in fulfillment and logistics. For example, you can use machine learning to predict like demand forecasting and make better predictions of what you need to have in stock so that you can fulfill and you can satisfy the demand of customers. But you can also use that in voice recognition and develop like better experiences in terms of Alexa and Echo. And the last dimension where we are very active is like bring machine learning, those tools to the hand of every developer, where we want, well, any developer to be able to apply a binary classification model to their specific problem. And so those algorithms can be made available in the cloud to ingest the data and learn at scale, and then like tackle a very broad range of applications, like the binary classification problems I talked about in the beginning. Thank you.
Thank you very much. Are there any questions from the floor or perhaps from the BCast? Okay, thank you.
Machine learning tools have the growing capacity to not only predict choices, but to influence emotions and thoughts. How to reconcile technological opportunities with the fear expressed by some individuals about their risks to form their opinions and take decisions independently of automated systems?
So I think that's a very complex problem. I think it's in general like the most classical ways of approaching that might lead to cases where you might have some depletion of the richness of what you show to, for example, customers. I think the recent trends have been to be a bit like, and this is typically when industries optimize like short-term metrics, but when you look at the longer term, well, you want to have like a richer set of information that you provide to customers. And there is some aspect there which is called like exploration, where you want always to explore the space to make sure that people see new things all the time. And I think there is like this is like how the trends are today, to essentially more diverse set of like offer more diverse sets of recommendations and product search results.
Thank you. Yeah, please.
Yes, this raises also a little bit the question about ethics. In ethics, I think that the rules will not be the same for a shoe manufacturer as for medical operators. Or there are already initiatives to come out with different levels of ethical rules regarding artificial intelligence?
So I think that's a very good question. I think there are the consequence of taking wrong decisions depending on the application varies tremendously. And so I think there's like we have to be much more mindful of when we automate decisions in the different domains, and think about, like, I think this is a social question, what are the right ways of tackling and what are the right guardrails. One thing I think is very important in practice is that those machine learning models can also output like the confidence of their predictions that they make. And that is something that is often overlooked, and that is helping making better decision when, for example, like an algorithm is unsure about the decision. Well, probably it's better to route that to a human, or to have like collect some additional information before taking a hard decision. And those are things that are possible today.
As a law professor, Viola Schmidt, Technical University of Darmstadt, I wanted to ask you, why didn't you include in your crash course the newest materials on AI law, ethics and robustness issued by the European Commission and the high-level expert group on AI? Answering your question, they have different definitions. What is AI? And the second point is they particularly institute a new multidisciplinary view on AI, combining lawfulness, ethical and technical robustness, which I call LER. And I wanted to contribute that there at the moment is an open innovation process inviting for feedback with the assessment list, how to implement, present and control AI challenges. Thank you so much.
I don't think that was a question. No, I think it's very fair. There is like this assessment at today, so that's like this open call for providing feedback on this list, which I think is very valuable. I think as many companies should try to participate.
In AI, what are the fundamental building blocks on which a developing country can access and deliver AI, ML benefits?
So can you start again the beginning of the question?
How to avoid the digital divide in AI? What are the fundamental building blocks on which a developing country can access and deliver AI, ML benefits?
I guess this is a very broad question. I think probably the first building block, fundamental piece is education, and I think there are today like a whole bunch of initiatives all over the world to make ML research more accessible, having the top academics speaking in all parts of the world. There has been like and conferences, so that's one way of bridging that gap. I think the other aspect is probably connectivity and having access to, for example, cloud infrastructure and broadband, so that you can leverage cloud. There's a wide range of tools that are available for any developer to use, but that of course requires that you have access to the internet and have a sufficiently broad, a good connection that you leverage those tools. I guess it's a much broader question, and I think that those are at least like two components I think are important.
Are there any other questions? And we're going to be moving on now to a blockchain. Sorry? Okay.
My name is Hussam El Gamal, and I represent developing countries. I'm coming from Egypt and from Africa. And I had, well, two questions, but it would cover as well AI, IoT, and 5G. Regarding 5G, how policies can help ensuring availability of the technology and no interruption due to country or company decision, especially for developing countries. We have seen an example of this between US and Huawei, and this is something really disturbing. So we need to see policies that would ensure availability of the technology, and also how policy can help ensuring resilience, privacy, and security on such international big data scale. The other one is related to the IoT. So when we talked about the IoT, the one thing is we are not yet having enough data privacy and security policies that are agreed on an international scale. Now for IoT, we have further challenge, which is OT security along. So again, we need to see international policies that would cover, or if there are any, related to OT security as well. And I think all of that would be under Industry 4. So how are we going to handle this, and how are we going to help developing countries also understand the challenges and maintain good policies to benefit from the empowerment of Industry 4 technologies? Thank you.
So one of the questions was about IoT security, and I think Wout had made a similar point earlier as well. I wonder whether I know that the ITU, there is a working group on security, and that the ITUD, the development sector, I would hope looks at this work and shares ideas and standards about how to improve security over IoT networks. That could be one place to look. And as I said, it's Microsoft as a company is looking to share best practices and work with other companies to develop best practices. But I hear what you're saying in that developing countries often look for international rules and standards which then they can apply, not just best practices. So yeah, the ITU might be one place to look.
Yeah, not just for IT, but for OT. So SCADA, critical infrastructure, etc. Because those are areas that we are not discussing in IT security. So how we are going to merge both and have a policy, because now they are going to be, as technology, they are going to communicate together, sensors that have different technology with the IT. And so we need developing more robust policies that would handle OT security along with IT security as well.
Are there any other questions? One more.
Thank you. Christoph Friedman from Eurochambre. You gave that very nice example with the machines learning 30 years ago to read numbers. And for me, that was one of the most classic examples, because that intelligence was then used to create these machines that can sort the post automatically. And when those systems were implemented in continental Europe, the biggest problem was the 7, the 1 and the 7, because where it was developed in Britain or the US, people tend to make just a straight line for the one, and the Europes make 2 lines. And the system always understood it as 7 because that was the only number in America that has these 2 lines. And it basically took 2 years to teach those machines that this can also be a 1 and to understand what's a 1 and what's a European 7. And now, based on this knowledge, I wonder how long does it take a machine to understand which dress is a summerish women's dress, which one is a bikini, which one is a house dress, which one is a... I mean, for me it's very difficult to just understand the process or these, how the machine can, from these many data, understand it. And I wanted to know when comes for you as developers the point where you shift from giving examples and teach the machine to let the system, so to say, operate more autonomously. How long does that take with today's technology?
So I think it should be clear that actually today, if you don't provide what we call training data, you're not able to learn anything. So we're talking about narrow AI. So you need to have examples of labels in this case, like that are typically provided by humans. And if you don't have the information, you're not able to learn anything. So that is something that people should realize. There's no magic in that respect. You need to have examples of those 7s, and that's why that's still the same situation today. So if you don't have examples of the 7 with the little bar or not, you will not recognize a 7. And you need a lot of 7s, like of the 2 types of 7s, before you can distinguish them. And so if you go back to the question of dress, if you don't tell that this is a bikini and this is like a dress, well, the machine will not recognize that. Here in this case, what's the type of models that we looked at? Well, they look at similarities between images. So it's not a classification problem. So it's slightly different. But if you think about classification, you always need a lot of training data. And that is something that people need to be aware of and is not always understood.
Are there any other questions, Bcast or live?
Yes, we have questions on Bcast. Can we say that AI is the mirror of society? How to eliminate the AI bias?
Okay, so well, I don't think AI has a bias. So the bias is in the data. And I think the 7 is an example. So there was some bias in this training data. There were only 1 type of 7s. And so the machine is not able to recognize this other type of 7s. And so that is something that we realized. I think what's interesting about biases in data is that it's even reflecting back to some biases that are existing in society. You just discover them because you've let the machine, like an algorithm, crunch through the data and reproduce some of the biases that are present in this data. So I think today people need to be much more careful in how they collect the data and make sure that biases can be detected and be corrected for. And that is something that wasn't as, was omitted or forgotten, like in the case of the 7 in the past.
Thank you. I suggest we move on to the next topic. Thank you very much, Cedric, for all of your answers. Our next speaker is going to be talking to us about blockchain. I'm sure there are going to be a lot of questions about that, Christophe. But first, we look forward to hearing your presentation. Christophe is Director of Public Policy and Internet at Telefonica. In his role, he oversees the strategy and development of Telefonica's global public policy work and defines its positions on digital policies, internet, and issues related to the digital economy. He is Vice Chair of the Business at OECD, BIAC, Committee on Digital Economic Policy, Vice Chair of the Commission on Digital Economy of the International Chamber of Commerce, and Chairman of the Internet Governance Working Group of ETNO. He's also a member of the Multi-Stakeholder Advisory Group of the UN IGF. He was closely involved in the founding of Alastria, the Spanish National Blockchain Consortium, where he is vice chair. He represented Telefonica as founding member of the INATBA, the International Association of Trusted Blockchain Applications. We look forward to your presentation, Christophe.
Well, thanks very much. And I will try to be short because I think we have another fascinating presentation coming up as well. So blockchain, I think after AI, maybe one of the issues you cannot avoid currently when you speak about any digital development. I mean, honestly, when I prepared the presentation, I mean, there are two ways of doing that. You know, you can do it to give you a general idea of what we're talking about, or you can go into details, and then I think after 5 minutes everyone is lost. So, so basically, I decided to go for the overview, and then we can kind of deep dive in questions if you like, and not to go too much into technicalities here. Basically, first question would be: is that a hype or is that real? I think that's the first question coming up to me at least all the time. Everyone asks, is that a hype? Everyone talks about, what blockchain would I like to have, and I think that that's the first question to answer when we speak about blockchain. And don't worry, I mean, there's not going to be only Dilbert comics in that presentation, so I stop here. So maybe you could do it, huh? And so basically, I think when you go back to these nice Gartner hype curve, very useful. This is one, and I'm sorry, I cannot read it, so I suppose you can also not read it, but what you see is that, issues like blockchain, and this is just for blockchain, it's not all technology, it's just for blockchain. Stuff like blockchains and ICOs and so on is already in the kind of delusional curve down there in the valley, and basically top you see up there stuff like smart contracts, for example. So you see that already. Blockchain itself has this kind of development of issues. Some are considered already old-fashioned, so to speak, and people are already kind of disillusionized by it, and then there are others coming really up, and they're really in the hype curve. I think the more interesting thing is that you see that the prediction is that there will be a transformational impact by the technology on all industries in the next 5 to 10 years. I think that's the time horizon we are speaking here. And that's basically, in a sense, the effect of combination of various solutions. I mean, first of all, there is the part of the ledger. Of course, it's not a book. You see a kind of old school ledger on the left, but some form of storing the data. This is encrypted, so it cannot be easily replicated, and then it's also distributed. So the storage is done not in one place, but basically across various places. And basically, when you combine these three kind of issues, you get to what we call a blockchain. If you kind of put it in other ways, you can see that there's a consensus element here, that basically all these kind of what they call nodes, basically the decentralized parts, they have to agree. And there is basically a way that you timestamp things, so there's a specific order, and so to speak, you cannot go back and change that order again. So only if basically all these nodes agree that something has happened, it really has happened, and all that is kind of basically encrypted, so you can be sure that this cannot be changed easily. In the end, because I suppose you're always thinking that's complicated, it's something like that. Or if I go back, well, it's coming up. So basically, it's a nice picture, of Donald Trump signing a law. And you see that everyone's kind of watching, and that's interesting. So basically, what you see is that all these people have to basically, if that would be a blockchain, there would be nodes, and only if they all agree that something has happened or has not happened, the information basically, which you might then encrypt of this document and put up in each node, only then this is the truth. So it is quite difficult to afterwards go back and say this has not happened, or this is not basically what we agreed on, or that's not the issue we were in that moment kind of agreeing on, because basically all these different kind of decentralized nodes have to agree that this really has happened or not. So that's a little bit, an easy way to kind of memorize the picture what a blockchain is. Of course, it's in real time it's more complex, but I mean that's basically the idea of it. When you look at how this works, you see this kind of up there, the chain of blocks. That's why it's called blockchain, if you've kind of asked yourself. And you basically see that each block has some form of a header, where there's a kind of basic information, especially what kind of node has been done before, what node comes after. This is all hashed in that header. There are more information there, timestamping and so on. And then the interesting part is what you see in the bottom of that block. Because I put in there a transaction, for example, there would be Bitcoin, so there's just the information that the transaction has been happened between two parties. And you can also put in there something which is called smart contract. That's basically what's happening on the blockchain called Ethereum. That would be a kind of automatically executable process. Which is currently kind of getting a lot of people very excited, because that means you can automate things. I mean, the moment something happens, something else automatically happens as well. And you could basically kind of put that in contracts, and you could kind of automate contracts, which of course, you know, you can imagine would kind of help a lot with many processes. So what you put down there in the box, the data, this information is basically, I mean, you're free to choose what you want in there. You can, you know, put all kind of information in there, which makes it so versatile for many different things. When you speak about blockchains, and the question comes up immediately, you know, there are like two different kinds of blockchains. There's something called public blockchains. They are called also permissionless distributed ledgers sometimes. And that's basically where anyone can write and read these blocks we just discussed. You know? So basically, Bitcoin, Ethereum are the most known ones. There are many others. They are basically open to everyone to use, and you can basically write and read. No one has full control of the whole blockchain. There are very strong consensus and mining processes for Bitcoin, for example, involved here. And basically, that's how the governance of the network is kind of set up. Then there is something called private blockchains. Some people say that these are not real blockchains, but I think it has generally been used now as a name, private blockchains. You see maybe the most famous ones are Hyperledger, Ripple. Sometimes there's R3 from the banks as well. Hyperledger is from Linux. So basically, they are only open to members. So only if you're a kind of member of a group, you can basically have a node and write and read on this blockchain as well. Usually that means that it's easier to govern that, because you can basically decide between the group of people what governance would you like. You don't have these kind of strong governance processes on the blockchain. And usually these are industry consortia. So these are the two things you can use. Basically, the most famous one, the most known ones are the public ones, but actually the ones more used in reality are the private ones, to be honest. And why is that so important, and why is everyone so fascinated about it? Because actually it adds this kind of layer of trust on top of something which you might call internet, you know? So, I mean, if internet kind of has democratized the use of communication and flow of information, blockchain kind of adds this layer of trust which the internet has not provided up to now. You can basically trace transactions, you can basically have them transparent, it's immutable. So you have a way of kind of creating between people who do not need to know each other a layer of trust that something really has happened and is the truth, so to say it in other words. So that's the key issue why businesses and people get excited about blockchain. There are many use cases. Blockchain is like the internet, a kind of all-purpose technology. So it's not that it's just for cryptocurrencies, as many people think. Actually, the technology can be used for many other things. You can basically tokenize and put into the block, I mean, that's tokenization, any form of information. There are many initiatives going on, for example, of certifications. So there are ideas around that. For example, universities could kind of certify your qualification, and then basically this is stored in a blockchain, and then everyone can have access to it. So that would kind of totally change the way we can certify to other people that we really did a degree, for example. and these kind of things. There are usage in the supply chain. I will show you in the next slide an example. There's usage for cryptocurrencies. Bitcoin, of course, everyone knows that. There has been, in the last maybe half year, a big hype around Libra, the Libra Foundation, an idea of a new system of cryptocurrencies you could launch. For digital identity is basically that the idea that you can, as a user of the internet, have a kind of self-governed identity. That means you decide what kind of information is in your identity, and these are basically kind of verified by all kind of different sources based on blockchain usage, and then you can basically use this identity in your interactions, and you can decide what granularity you want to give away of your identity. So you don't have to give, your ID, so to speak, or you don't have to use the login with some whatever social network you're using. You can basically have an identity you kind of control yourself, and you can give away parts of that. So these are all kind of fascinating ideas floating around. It is maybe in these areas where you see the best usage. All of that has the idea behind that you can cut out some intermediaries, for example, in the financial sector. I mean, you don't need someone in the middle kind of for a transaction across the world, kind of guaranteeing a bank, for example, that you really have that money and that money goes to someone else and so on. I mean, all these processes can be done peer-to-peer and not with intermediaries anymore. There's sometimes a usage for better traceability and more transparency. There is full transparency on the blockchain, and you can have this effect of smart contracts where you can automate a lot of the processes we use on a day-to-day basis. So the use cases are just coming up. There's a kind of explosion of ideas. I said before in the slide that blockchain is like the internet 25 years ago. Maybe that's the best description. I mean, we're in the year 94 for internet, and we haven't even started seeing the real commercial implications of all of that. One example of what it might be, and that's one from my company, but in Brazil, for example, we have started to track the installation of the routers, what you see up there on the right, the internet routers in the house of our customers. We track that now all on the blockchain, so every kind of handing over of that device across the whole value chain, from the production of the single parts of the router to the assembly in the country, to the installation by the employee of Telefonica or third parties in the houses and premises of our customers. Sometimes the return of all that if something's not working, the information why something has not worked, what has gone wrong, and so on. All that is kind of stored, and basically that has given us a really unprecedented transparency and efficiency in what we do in this installation process. It's a kind of supply chain. I mean, there are many others in the world you could kind of copy, but I just wanted to show you that this is really operational. This is used day to day. This is not kind of proof of concepts or something. This is working. We have 800,000 transactions a day on that blockchain, so it's quite a powerful platform. And basically, we are quite astonished when you use on top of that other technologies, and with that slide I end, if you use the blockchain as a basis and then you put on top AI, IoT, and all these things which are big data we are discussing as well here, you can see that it gives you a fantastic, interesting return on efficiencies, on transparency, and on improving basically processes for companies. And so that's why I think people are rightly excited about the whole technology. So thank you.
Thank you very much. Now you heard Christoph. He was going to give you an introduction, and then he was going to turn the floor back to you to ask questions for a deep dive, so please don't be shy. Who has a critical question for Christoph? A challenging one. Ah, okay, over here.
Hi, my name is Basil. Regarding blockchain, you were talking about traceability as a feature of the transaction. So how does it affect an end user's ability to remain anonymous within the internet?
it's traceable, but that does not mean that it affects your privacy. So the information, if you think about the block I showed you, the information on the bottom, what you put in there as the real information about you, this is encrypted, so it's not visible. What you might see is just the header. So basically, you can see that transactions has happened, but you cannot see the real information. So you can have both. I mean, it's not that it's traceable does not mean that it's not anonymous.
What are the advantages of using blockchain for your supply chain tracking product over a normal database system?
Excuse me, I didn't get that.
Yeah. What are the advantages of using blockchain for your supply chain tracking product over a normal database system?
Yeah, I mean, that's a very good question. I mean, that always comes up, and actually it's maybe the first question you should ask yourself if you want to do something with blockchain. I mean, why cannot use just a database? The reason we did it in Brazil and blockchain is that the supply chain is not all under our control. So basically, we control parts of it, but I mean, of course, it's a much broader one, and it's easier to kind of coordinate all different kind of suppliers, but also then afterwards, we have kind of third-party technical services and so on. It's easier to do it on a blockchain, so that's why we did it on a blockchain. So it's the idea is that you can involve many parties, while a database usually you have to use the same kind of underlying software. Not everyone is using the same, and so on. So that's the reason why we did it on a blockchain. But it's a very good question, and actually very often I think you can use also databases. Yeah.
Thank you very much. My name is Jimson Olufie, and sorry I came in late. And Christoph, the portion I made was quite interesting. Well, there's a recent report that blockchain has been hacked. And then there is Ethereum cryptocurrency, and a lot of money is stolen. So I don't know if you are aware of that, and what measures could be put in place to ensure it doesn't happen. Thank you.
Well, thanks for the question. Yeah, it's true. I mean, I think blockchain has quite a high security standard, but I mean, it's not totally, I mean, as anything is not totally secure. Also, blockchains are not totally secure. I mean, I don't want to go into the details of why it can be hacked, because I think it's very complex. But I mean, you have to be aware that there are security aspects involved in that as well. The moment there's a lot of value, of course, you know that people get very interested and find kind of ideas to break things. I think that therefore it's important to work right from the start with the idea of resilience in the blockchain system as well. And I can tell you that in the initiatives I see, at least around in Spain, in Europe, and other places, people are very well aware that you need to kind of think about these things right from the start. But then again, there are so many blockchains, so I mean, it depends really how you set it up. There are also issues around, of course, we said it's immutable, but of course only if there's this famous 51% problem. I mean, what happens if someone can take control of the majority of the nodes and then can rewrite blockchains and so on? These are all very technical issues, and I think people are aware of the shortcomings as well. I mean, I could ask you the other way around. Tell me one system which has not been hacked. So I think there are not too many around in the world. So I think maybe we have to be also, as I said, very early developments. There's learning on the way to do. But I mean, especially it happened around cryptocurrencies where there's a lot of value involved and so on, which is a high risk environment, of course.
Hello, my name is Agatha Freire. I'm a law professor, and my question to you is, what would you say is the biggest challenge and obstacle to blockchain becoming mainstream? Would it be scalability, or would it be perhaps efficiency? How would you describe a lack of regulatory certainty?
Yes, that's a great question as well. I mean, I think that honestly, especially for public blockchains, I think it is more the legal regulatory compliance. I think that our systems, and I'm a lawyer myself, our systems are not thought for decentralized kind of entities and systems. I mean, we always believe that there's one responsible. So the question would be, who's responsible? And so a lot of questions come up around that, and people say, so who's responsible if a thing goes wrong? Who's responsible if things get hacked and so on? And there are many questions around that. I also, again, ask the other question, I mean, who's responsible if internet comes down? Who's responsible? And we're still using internet every day, and more or less it's working. I mean, that's also the good thing. But I mean, I have to say that that's an issue you have to work on, and there are ways around it, but we need much more work in that area. Regarding private blockchains, that's one of the reasons why I think a lot of companies tend to use private ones currently, is that you can construct a system between the people involved in a way that you can be compliant. So there it's not so much an issue, but especially for the public ones, you have the scalability issues. I mean, the mining in itself is very energy consuming. There are problems of throughput because you have to copy all of these information into all the nodes. This is all better in a private blockchain where you can, basically have less nodes. You can basically set up the governance between the parties. So the reason why people use, for example, Hyperledger quite a lot in a company environment is that they have no scalability problems and no issues around the legal compliance.
How do you assess the environmental impact of blockchain over the next years? And how can we limit energy usage and still profit from technology that needs a lot of server capacity?
In the beginning was, sorry, how can you?
How do you assess the environmental impact of blockchain over the next years?
How we assess the impact of blockchain?
Environmental impact of
the
blockchain.
Environmental impact. I mean, as I said, I mean, that's something for the public blockchains. It's not happening for the private blockchains where the impact is not at all, because the impact of the public blockchains is the process where you have what they call a proof of work. A proof of work where you have to show, and the proof of work is usually calculations, and the calculations are very time energy consuming. I think there are ways of calculating that. I've seen amazing numbers of the energy consumption of blockchains. I'm not quite sure how you can, how true these are, and how you can assess them, but it's true that it's an issue, and I think people are aware that environmental impact of public blockchains are a serious concern. Again, there are many ideas, without getting into technology issues, but there are many ideas how we can improve that. There are new ideas around. And I mean, to simplify it totally, I mean, maybe you don't have to copy then, everything to all nodes. You can use just, maybe the last 21 and the next 21s. Then you have security issues coming up because you don't have the same immutability. There are other ideas that you can say. You might be able to not use such a proof of work. So the calculations which are done for nothing, I mean, just to show that you can mine the block, can be maybe changed to a different kind of proof of, and so basically these are the ideas around. So I think people are aware, but yes, it's an issue.
Thank you very much, Christoph.
Thank you.
We're going to be moving now on to the topic of smart cities. I'm going to be introducing you to Svetlana Grant, Program Director, Internet of Things Program at GSMA. Svetlana has over 20 years of experience in mobile industry. She has been part of the GSMA IoT Connected Living program since 2009, working on the development of the embedded mobile guidelines and managing the smart energy and smart cities market development projects. Thereafter, Svetlana led the IoT Networks project and the Mobile IoT initiative, working with the industry to identify emerging IoT service requirements with a focus on low-power, wide-area technologies. She's currently director of the IoT program. Over to you, Svetlana.
Thank you very much, Sophie. Thank you, everyone. I think it's in fact quite fortunate that I'm speaking last, because smart cities is a combination of all of these technologies that we've just discussed, if nothing else. And in fact, I was curious, how many people in the audience live in a city? Can you give us a hand? 98%, possibly. And how many of you do you think live in a smart city? Ooh. So that's really interesting. I thought that I would completely skip the definition of smart city because I thought, well, surely these are the beasts that are very well established, and so we needn't speak about that. But maybe it is a good idea to define what a smart city is, and therefore, do we actually have them out there? First of all, the GSMA, for those of you who do not know us, we are the Mobile Industry Association, and we work with over 800 operators globally and about 400 companies who are supporting the mobile industry and making it all happen. We are very actively working with the ministries, telecoms regulators, and international and non-governmental bodies. And a very big mandate for the GSMA is the connectivity for everyone and everything for a better future. And so big focus at the UN Sustainable Development Goals. And of course, cities are one of the vehicles to get there with the Sustainable Development Goals. But back to what a smart city is. I started working on smart cities about 7 years ago. And at that point, back to the hype curve that Christoph shared, smart cities were possibly approaching the very top of that. And everybody was talking about them, and everybody had projects and pilots, dozens and dozens of those. And when we started looking at the smart cities, we decided that, if we wanted to define it, that a smart city would be a city that collects information about its assets and about its services, primarily public services, the services for the benefit of its citizens, but not only collects this data, but in fact creates information and intelligence with this data. Namely, it processes it, it applies some models, and then, most importantly, makes decisions based on this data. And I think if we look at the cities out there, by and large, there's a lot of connectivity. So when we have doubts about whether smart cities exist or not, it's probably not so much about the fact that things are getting more and more and increasingly connected. And of course, smart cities make really good use of the mobile phones and all of the infrastructure around them, free Wi-Fi and so on, plenty of connectivity. It is not that. I think it is that step between collecting and processing data to actually having some sort of a view of that data and ability to act to it that stands as a barrier to the emergence of the properly smart cities so far. And let me share with you a little bit about the journey that I have made with the smart cities, because before we talk about technologies of the future for the smart cities, I think it's useful to take a look at what's happened in the last 7, 8 years. What worked? What hasn't worked? Why do we still have doubts? And the first couple of cities that I visited at that time were the South Korean smart cities. And those were the Busan and Seoul, some of the most proactive and most forward-looking cities at that time. And if you look at that picture, which I realize is extremely difficult to see, but let me describe what's on it. First of all, it is a bus shelter. And it is a bus shelter with a smart monitor and the information board where all of the bus times and other information is showing. And I think that bit has become quite real in most cities. It also has an environmental sensor on one of the sides. And again, that actually is something that is becoming more widely available. And I'll show you a couple of other projects that are doing exactly the same thing. And obviously, there is a surveillance camera, and that has become probably the highest pitch type of connected device in the cities that we see a lot of, and a lot of discussions, many different angles. But even then, 7 years ago, those were widely already available. And if you look at the first wave of the applications that were deployed by smart cities, a lot of them were around transport. So we tallied up some of the projects in 2012. We had just about 240 odd projects where we could track the participation of mobile operators. And we could see that, about 100 of those projects were all around transport. And in fact, not just transport, but most of them were around ticketing. And again, interesting to look back and realize that now, the NFC-based, the payment types of cards have become quite widely available. And in many cases, people do not necessarily view them as part of the smart cities, just something that's out there. going back to that whole definition, is your city smart? Well, that was considered one of the criteria of a smart cities 7 years ago, and it's become just kind of a matter of life for all of us. A good just under 100 projects at that time were all around energy. And if you look at the types of projects that were in place at that time, they were all around creating awareness and providing readings of the energy consumption for businesses and for consumers and for cities themselves. So a lot of smart lighting projects were experimented with, and actually that development still continues. There is a lot more there's a lot more to it, and those projects are not still as entrenched as we'd hope to see. And then there were a lot of municipal types of projects, waste management and so on. And interestingly, those are the types of projects that very often we do associate with smart cities, and actually we see very few of them. And the reason is that a lot of cities play and experiment and run pilots and proofs of concepts, but very few in fact go on and invest. Very few can prove the business case, and even where the business case can be proven, the cities tend to be very risk averse. They do not want to invest into anything that they might potentially need to commit to for many, many years as an investment. They're looking potentially for capex-based projects, and they generally continue doing things by inertia, the way they've always been doing them, collecting the rubbish, providing the street lighting. Very, very rarely do projects come up where they are a new build and actually the opportunity arises to create something from scratch. So even there, we've identified a few of the issues with why smart cities have not necessarily emerged as we'd hoped to see them emerged. And when I started doing this review, I thought, well, has nothing changed and has nothing really evolved in the smart cities? But in fact, it has, right? And there is a very interesting technology story emerging in the smart cities. And one of the things that has emerged is the purpose-built IoT types of networks. So 6-7 years ago, the very first unlicensed technologies made the appearance. So this is the likes of LoRa and Sigfox. And then roughly 4 years ago, licensed cellular technologies made appearance in the market. Those are the technologies like NB-IoT and LTE-M. Those are built specifically for tiny little sensors that communicate very little bursts of data, that are very energy efficient, and that can reach very, very far into the underground and also in the open agricultural type of scenario, very far into the fields. And for the cities in particular, this became quite important because previously, where you needed to monitor, for example, networks that are deep underground, water networks, for example, of pipelines and so on, you really had to look at building a network underground, purpose-built for those types of scenarios. But with the new technology, it became possible to deploy this new tech on top of the existing infrastructure and basically make them work for the cities. Another thing that changed is, what Cedric has described and what we've also heard Ben talk a little bit about is the emergence of the data analytics and the processing, so machine learning and AI technologies. So a lot of compute power started going into those projects and made it possible for the cities to implement some of the intelligence and processing that was not necessarily possible before. Networks have become faster, LTE, and now 5G coming on board as well. So that's obviously helped, especially when we're talking about all of the real-time data processing, which is a huge trend, and a lot of impact that we already see. And also the use of cameras. And actually not just use of cameras for surveillance, but actually using camera as a sensor for all sorts of scenarios where you would have the old established infrastructure. A retrofit of a camera can actually process a lot of information and collect intelligence that was previously possible only through the installation, physical installation of the sensors, which is difficult in the cities where you need to go and touch every single type of asset that you might want to monitor. It's labor intensive, it costs a lot of money, and it generally, slows down the adoption of this type of scenarios. So what did it mean? Well, if we look at kind of what is happening, the bulk of the projects and the stories in the smart cities today, I call them the stories of water and dust, because a lot of them are all around the monitoring and the management of the water infrastructure. air quality and a lot of management of the pollution. And so we've seen a big wave of new projects. So here's one example. This is called WaterSense. This is the US example where the EPA, the Environmental Protection Agency, has been running the WaterSense program for their citizens. It's a much bigger program than just the IoT and so on. It's a big education program for people who basically use as much as a third of all water on their outdoors watering. And so there's been a big education program, and generally what we have seen is now the proliferation of connectivity for rain sensors, soil moisture sensors. Those have become so affordable that it is now a mass market type of product. And it's a great development for the cities and for the homes and buildings that make up the cities, because the impact is in fact pretty considerable. If you look at the savings in the water, you are basically looking at anything in a big range, from 30 to 60% savings in the actual water consumption, and obviously it's the savings for the consumers as well. So this whole decline in the cost of sensors made a big impact as to what's been deployed in the cities. This is the retrofit scenario that I mentioned to you before. This is an example of Las Vegas, but there are many, many projects that are currently being deployed and developed. This is effectively monitoring the infrastructure in the cities and acting on the pipeline leaks before the infrastructure generally fails, before sinkholes develop, before it becomes a multi-million problem. And that's actually one of the areas where the cities were able to justify the investment, because the impact of the infrastructure failing and the water leaks developing to a very large extent is a multi-million problem, and the impact of failing to prevent it is visible very clearly and very easy to justify working on. Here are the projects that we've seen, and we'll probably see more and more in the future. This is one example of in Taiwan, of Taipei, where climate change and extreme weather monitoring is taking place. So this is the near real-time data processing, where a lot of sensors are tracking either the floods or the rain levels and many other things. So if you're looking at kind of the types of devices that are being deployed, a lot of them are using LTE at the moment, but increasingly we see that use of very narrowband IoT-specific technologies and a lot of data analytics. You can see there on the right-hand side the disaster prevention systems, which are integrating a lot of information from a lot of different sources and create some intelligence and warning systems and alerts and so on. So we expect that there will be a lot more of this in the future. Here's another example. London Big Data Air Quality Initiative. We have worked on this project for since 2016, and this has been a truly representative of a smart city type of combination of sensor data, satellite data, and also the application of machine learning methods to correlate the movements of weather patterns and traffic movements, to correlate the information you can collect from the mobile phones, which identifies where the congestion areas of a lot of people are, and looking at what kind of impact those have on the air quality. And so here, obviously, we're not talking about dust in particular. We're talking about a lot of different elements that can be tracked. It's carbon monoxide and so on and so on. But in fact, we have seen a lot of offshoots of this kind of initiative in many different cities, and I think this is one of the probably more difficult ones for the cities to justify in financial terms, because it's very difficult to track the impact of poor air quality on health. Very few studies are there. They are there, and those impacts are very well identified. So we expect that there will be more, but the city does not necessarily see an immediate financial impact and an impact on its bottom line. So I think it's one of those projects that we hope to see more of, because they're extremely important, and they are now possible. If you look at previously the cost of sensors being in the range of $3,000 to $4,000, very highly specialized, very complex chemical sensing that combined a lot of different elements sensing inside. Now, we can see the sensors that are $200–300, so it's been a factor of 10 decline in the costs of those. Sometimes they're simpler, sometimes they're tracking only 1 or 2 types of chemicals, but it works because you can deploy them in a lot more places and you have a much better picture. And you probably have all heard about various digital twin initiatives, so this is one of the things that is happening in the background that will make all of those digital twins in the smart cities possible. So, having taken a look at what's happening today, what do we expect to see? Well, I think the main thing, the main technological requirement that smart cities really have is that whatever technology they deploy, it needs to scale, it needs to be low cost, it needs to have a long lifespan. This is back to all of that requirement of, being able to retrofit, being able to provide, hundreds of thousands of sensors to have a proper representation of the full city pictures. And cities are effectively very cost conscious, so they do want these sensors to continue declining, and they also want to make sure that the data that they collect in different parts of the city can also be read regardless of where the boroughs or the little city councils are, and they also want to make sure that all of that open data that was a big kind of buzzword 7 years ago, that's become reality of life. So they want to make sure that all of this data is accessible. So if you look at the City of London, they have about 800 open data sets, and they're working to have one API to make sure that any developer can open that and access that data set. They want to make sure that whatever they install behaves as they expect it to behave, so that's the quality of service, and that's kind of leading up a little bit to that 5G deployment, which will make this QoS a lot easier to implement. Data security, I mean, it's a huge requirement. It's a topic in its own right, and I think we can talk about it. I'll mention it very briefly, but we could go on. It's not only the protection of the data about the critical city assets, but of course it's also protection of the data about the citizens themselves, and it's knowing that none of that infrastructure basically can be used to any undue purpose. So big requirements. So that's a kind of a list of the requirements that cities have, and some of them are already being catered to. So that's really good news. We expect to see more happening. And 5G is going to bring three capabilities with it. And I think that Marie already mentioned quite a few of them, but just a few to mention. First of all is that scale, that massive IoT. This is what we call mobile IoT today. This is the networks that are already being installed, and they're already part of the 5G specs, so they're going to roll seamlessly and be integrated into the 5G networks that will be deployed over the next couple of years. This is all of the ultra-high, really reliable, low-latency infrastructure, which will be important for autonomous vehicles, which will be important for emergency vehicles, ambulances, public safety services. So that's the kind of capability of the 5G that will be useful for the cities. And of course, enhanced mobile broadband, it's all of that near real-time data processing and application of machine learning models and application of AI and support of all of the camera traffic that will be generated. So all of that is going to be riding on the mobile broadband. So when we talk about 5G for smart cities, we do not talk about a specific, very highly souped up type of network. We talk about 5G era. We talk about combination of technologies from Wi-Fi to NB-IoT to 5G, very low latency, high throughput, to a combination of satellite and so on, and the ability of a core network to deal with all of those technologies and orchestrate and moderate between all of those different technologies. And yeah, that's the sort of infrastructure that will be supporting all of the demands of the cities. The cities do need to incorporate all of those IoT devices, and they need to be secure by design. And it's become a bit of a kind of the word that's used very widely, and very few people kind of think deeply about what exactly it means. And it simply means that from the very, very start of thinking of a product, security needs to be, and privacy, in fact, they need to be kind of thought through from the very incorporation of a chipset all the way to the then transmitting that data into the cloud through the public or private networks and actually being safely stored there in the cloud and released only on the need to know and need to access basis. So we have worked with a number of global organizations to build the best practices and to develop policies for security. We have a range of guidelines that have now become references in a number of other organizations to make sure that we create this aligned approach to the IoT security. And most importantly, we are trying to educate all of those little IoT companies. A lot of them have never had any experience in building for either consumers or businesses or cities. So they come with a great idea and they need to understand how to incorporate it very safely into whatever they're going to bring into the market. So we're building a network of labs that are testing, certifying, self-certifying all of those devices. But it's a very, very early start to what effectively needs to be a big job on security. And last but not least, the challenge that the cities are going to have is how to incorporate all of those lessons that they have seen, a few pioneering places implement and adapt it to their own circumstances. We dealt with it a few years ago when we built the model for the London air quality. And one of our operators, Ferrystone, deployed it for the government in Taipei. They found that the model worked, but it needed to be tweaked and it needed to be retrained and it needed to be adapted. And I think that's the challenge that every city is going to face and already facing. They need to effectively understand the best practices that are out there and process them and apply them to their specific situations to make them properly work. Because we found that, creating a city blueprint that works well for one city does not necessarily mean that it's the same blueprint that will work for any other city. Cities do need tweaking and they need customizing. And that's probably the challenge that will remain for the cities for the years to come. So in summary, we believe that a range of 5G, AI, and IoT technologies is going to be the combination for the smart cities of the future. The good news is that all those years, the cities have been looking around and a few of them have been doing things and a few of them have been experimenting and implementing truly innovative services that are self-sustainable in the financial sense of this word. And they're learning. They can see things work and they're very slowly, in a risk-averse way, starting to adopt this. So we are optimists about smart cities, but we think that there needs to be a lot more done to actually make it work and to release, a whole lot of that trillions of economic value that is forecast by analysts and consultancies and make the cities properly work. But exciting times to come. So that's the conclusion, hopefully, an optimistic conclusion to this presentation. So thank you very much, and I look forward to your questions.
Thank you very much. So who would like to take advantage of having Svetlana here and asking a few questions? We have one already, thank you.
Hello, everyone. I'm Melvin from Hong Kong. So with the fundamental and significant development of smart city and advancement of the 5G network, how can we ensure that the privacy of persons is well respected? Examples of misusing these new technologies are never a new thing to hear about. The worrying trend that some countries are using their network infrastructures, sensors, and surveillance cameras to collect information about their citizens more than required, raising concerns of losing privacy. It's really alerting. How can we ensure that our privacy is being well respected in the era of smart cities, as Article 12 from the Universal Declaration of Human Rights protected? Thank you.
Thank you very much. Well, I think it's not just a question about 5G, is it? It's a question about any network technology and how the governments and the cities deal with it and how they deploy these technologies for the benefit of its citizens. And it's always a balance. It's a balance of safety versus, the human rights and so on. I think it's a massively complicated topic and very important to raise. 5G and everything else. That's probably all I can do is to acknowledge it, indeed.
Thank you, please.
Thank you very much, Jameson Olufuye. That was an interesting presentation. My concern is with regard to the security aspect. I felt not much emphasis being placed on it in terms of risks, just as the previous speaker mentioned. Today, with regard to abuse, we're looking at losses up to $6 trillion from estimates, and it's going to skyrocket by the time we now connect all this. And a little arc, a little infiltration could cause humongous damages. So yes, design, security by design, very, very good. But I think we need to place more emphasis on preparedness. You know, this technology is there, but what we need, based on what we have been seeing now, the challenge we have with regard to abuse, with regard to risk and damages, we need to place a lot more emphasis on what we need to do. Preparation, maybe like a whole team, get ready. As we work on the smart city, the city administrators need to really look at the governance aspect of mitigating this. It's absolutely essential, because if electricity is cut, you can easily remotely do that. Water is damaged, remotely do that. And even citizens, they are really harassed and terrified. And so a new ball game is coming up. So just a little advisory that maybe subsequently it would be necessary to place more emphasis on the governance aspect to ensure maybe leaks or acts or issues will be tackled. Thank you.
Well, I can only agree with what you're stating as a major risk and a problem. And I think it's the consistency of approach in many different sectors and from many different actors in this ecosystem that I think is going to be important. So you talked about policies, obviously that's important. It's a very fast evolving area, and it's very often down to single actors and single people coming up with hacking ideas and so on. I think there needs to be a great deal of coordination to be able to react quickly, and that's something that we have been working for a while too. And it works really well in the areas of fraud, for example, for mobile networks, and it's the ability to share information, it's the ability to act on it quickly if it's identified in one area and very quickly be able to react. Because, as was stated, we do expect this, the digital footprint is growing. It will only continue to grow. And that means that the attack surface and the is becoming bigger and bigger. So I think it's how we react to it that becomes truly and properly defining as to how big it becomes. So yes, starting from the very sensor device manufacturers, going all the way through the ecosystem. And I'm thinking IoT really, but all the way through the networks, cloud services, hosting, and actually educating the citizens as well. This is where you need to be wary of disclosing your data. This is where it's the youngsters who are very social media kind of friendly, who are never worried about disclosing anything about themselves. So it's that whole big chain of education that I think would be crucial.
Thank you very much. Please join me in thanking this expert panel that we've had today. I know it's been a very long day. A lot of you have traveled from very far away and you're battling with jet lag and a lot of other things. So thank you to all of you as well for being a very active audience. I hope you enjoyed today's panel and you feel even more empowered and more informed to take part in the IGF. The experts are still in the room. If you have any questions for them, I'm volunteering them to you. If you have any last questions, I don't think they'll talk to me anymore, but please. Thank you very much. I wish you a very good evening and I hope you enjoyed today's panel.